is Don Sherman. We're going to be talking about an architectural overview of Pega and Pega BPM today. The agenda we're going to go through is we're going to look a little bit at the product landscape of Pega, so the different sort of frameworks and components that make up the overall Pega system product offering. We're going to look at the architecture of the product from both a functional perspective as well as a technology perspective. We'll look at engine architecture execution, and then we'll look at some things like security. We'll look at monitoring and management. We'll look at the life cycle of deployment, etc. So a level set to kind of get started on the product architecture. Pega goes to market in a couple of different ways. The first way we go to market is with the core product that we call PRPC, which stands for Pega Rules Process Commander. You'll also hear people call that Pega Rules. You'll hear them call it Pega BPM. Sometimes we'll just call it Pega. That's the core engine that does business process management, business rules, user experience, case management, integration. It has the whole design environment that represents what we call directly capture objectives, or DCO. That's our core product. And I would say probably about 30 to 40% of our customer base uses that by itself as a platform to build business process, business rules, case management applications. We also have in key vertical markets taken PRPC and used it internally as a development environment to build out what we call frameworks. And these frameworks aren't net new technology or net new code. They're just pre-built assets, processes, rules, screens, etc., built in PRPC, much the same way that our customers would build an application in PRPC, but packaged as a starting point in key vertical industries. So things like financial services and opening a new account or managing payment exceptions, or things like healthcare in terms of processing claims adjudication or onboarding new customers, or things like insurance and managing global claims across a wide enterprise. We also have some frameworks that are more horizontal in scope, and perhaps the largest of these is what we call CPM, or Customer Process Manager, where we've literally taken the PRPC technology and through building of processes and rules and screens, enabled it to be a full customer service desktop. So things like telephony integration, providing a 360-degree view of the customer, dialogue scripting, what we call interaction management, that whole picture. We also have frameworks that are built on PRPC that are more operational. So managing things like project management, actually driving the process for completing a PRPC project, or managing the testing of a PRPC project, or as we'll see in a little bit, managing and monitoring your existing Pega implementations. The key thing to understand about all these frameworks is that they are just pre-built processes and rules and screens in PRPC. So as we talk about the architecture of PRPC today and the technology that underlies it, it's going to apply to those frameworks as well. Excellent? Okay. When we look at PRPC, what we're looking at is a JEE architected Java-based application. So down at the bottom, you've got a database layer. That could be Oracle, that could be DB2 on a distributed system or up on the mainframe, or that could be SQL Server. And inside that database, we're storing two types of assets. We're storing what we call the enterprise repository, and that's the definition of the business processes and rules and screens and interface points that make up your applications, as well as what we call the work database, and that's your processes in flight, or cases. So the process state information, the business data around that process, the audit history of what's happened over the course of that process, artifacts and attachments, whether we are storing them locally inside the work database, or more likely, storing a pointer to a enterprise content management system like FileNet or Documentum that you may have somewhere else. And of course, both at the enterprise repository and the work database level, we provide capabilities for federating that, so I can either have a single repository, or I can have multiple repositories that share assets, say, across a very large enterprise. Also down at the data layer, of course, are your own database applications. So your own databases on your own database platforms that Pega isn't managing, but Pega may be accessing via JDBC as a data source. And of course, we have a tool called BIX, or the Business Intelligence Exchange, which allows us to do rapid, incremental, or full extracts of any of the data in the Pega database to push out to a data warehouse platform. The next layer up at the application tier, we're running inside a JEE application server. So WebSphere, Oracle, WebLogic, JBoss, or a lightweight application server, a web container like Tomcat, were deployed as a very small EAR or a WAR file. But as we'll see later on, the business logic remains down in the repository. So as you make changes, as you grow out your application, you're not changing that EAR or WAR file, you're just deploying new logic to the repository. And again, we'll talk about how that happens in a couple of slides. Finally, the client tier is entirely browser-based. That's browser-based for deployment or design time, so whether I'm building processes or rules. That's browser-based for my end-user environment, whether we are the full enterprise dashboard, like we might be in, say, a CRM or CPM style solution, or whether we're a very small chunk of an existing screen implemented through a portlet technology like JSR 186 or JSR 168, I'm sorry, or 286, or whether that's through a mashup technology, kind of like Google Maps, where I'm sticking a chunk of PRPC UI inside an existing web page using JavaScript and JSON and AJAX to do sort of dynamic binding, and we have an out-of-the-box mashup API that allows you to do that. And that kind of sums up the overall architecture of PRPC. So if we want to start drilling into that design time environment and think about what the functional architecture means, we can build it from the ground up. So we talked about our databases. We have the enterprise repository and the work database. On top of that is the object persistence layer. So this is what understands the objects that make up my cases or my work objects. And that may be data types and object definitions that you put into PRPC. They may come with one of the frameworks that you bought. So for example, our financial services frameworks know what a customer looks like and a bank looks like and a transaction looks like. Or you may have imported those object models from XSDs or Java stubs or existing databases that you already have in your enterprise. The object persistence layer is responsible for mapping that very nested object structure down into a relational database. And we do that by having hybrid structures down at the database. So if you look at most of the PRPC database tables, you'll see a lot of relational columns, and then you'll see a blob or a binary object storage. And what we're doing is we're storing the object in that at the end of the column, and then exposing select fields out of that object either into relational columns or normalizing them onto additional tables to build a fully normalized form. And the goal here is to deliver optimal performance and flexibility. So by having that object storage there, I have the ability to read the entire object without going to multiple tables, which for a lot of keyed reads into a database is the fastest way to get the data. But because I've selectively exposed things as columns, if I need to do a list or I need to do a report, I avoid the blob altogether, and the engine is intelligent enough to do that, and just scan through the database columns using traditional database SQL. But because the object structure is metadata driven, because it knows its structure, I can do things like add a field dynamically without having to rebuild my database table. So while Pega is using blobs under the covers, we're doing it both to drive performance and to drive agility that you wouldn't get from a normal, purely exploded, normalized data structure. The next layer up from that is the business rule services. So this is the ability to define business rules like decision tables and decision trees, to define the execution of business rules, etc. In our latest release, thanks to the acquisition of decisioning technology from Chordiant, that business rules layer has expanded to include not just traditional decision tables and trees, but also predictive models. So being able to take a set of data about, say, a customer base, interpolate a statistical model from that. So this type of customer is likely to respond to this type of offer, build an algorithm around applying that statistical model, and then execute it inside of PRPC right along with your other business rules. So it's allowing us to create a whole new world of solutions that you're going to see us bringing to market in things like marketing and collections, etc. The business rules supports full backward chaining, so inference and being able to derive values, derive calculations. And we actually have Pega customers who use us purely as a business rules engine to do things like underwrite mortgages or price insurance, etc. And you see Pega PRPC show up as a leader on the business rule magic quadrants or waves, and it's the same product that's going to show up also on the BPM and case management magic quadrants and waves. Which brings us to the next layer up, which is business process management. So the ability to model and design the business process. You can model your process in Pega either using Visio plugged into your browser, which we like because it fits the tool that most business analysts are most familiar with using. But we also allow you to use a browser-based, pure sort of drag-and-drop form for modeling as well. So you can either go completely client-free, just use the browser, or you can dynamically plug into Visio and use a very familiar tool to design your processes. We support stencils like BPMN for designing the process. And then at runtime, we allow you to execute the process, drive things like push and pull-based routing, skill-based routing, work queue and work list management, out-of-the-box controls for bulk transfer of work from one list to another. All of that capability comes core with the product. The next layer up that's interesting is case management. So I think if you're doing long-running business processes, if you are managing a process across multiple users that isn't just transactional, you're ultimately doing case management because you're managing the data that flows through the process, the attributes, the audit, the artifacts, etc. So Pega has always had very strong capabilities around case management, around managing parent-child relationships between those cases. So for example, an auto claim, parent case, may result in a personal injury claim, a vehicle claim, an other vehicle claim, another personal injury claim. Maybe you even hit a street sign and there's a property damage claim in there as well. So being able to manage those child cases and relate them back up to the parent. In the last couple of releases, we've invested a lot at making the design time controls for building those cases much simpler and much faster in terms of configuring case definitions. As well as expanded our case processing into the world that I would call ad hoc. So there are some business scenarios where the business process is not well defined. If you think about long-term care or care management, I'm going to have a case that lives for a long time, and the tasks and steps I do on that case are driven not by a process, but by events, or by other tasks, or by contacts. So the case management layer of Pega allows you to track not just your static processes, but your much more dynamic, much more ad hoc processing as well, pushing the power of BPM out into sort of what sometimes gets called the knowledge worker community. You also need to put a user experience on top of this. And when we've looked over the past 10 years at projects of customers rolling out applications, it's amazing how much of a percentage of the overall project cost is tied to user experience. Because as users become more familiar with web-based applications, as they touch Facebook and Google Mail every day, they expect a very dynamic, rich feel from those applications. But as developers, we don't have time to invest in JavaScript development and trying to maintain JavaScript and find security holes in JavaScript and ensure that it performs across multiple browsers, etc. So with Pega, we've pushed over significant investment over the last couple of releases to allow what I call a no-compromise user experience. Being able to build the dynamic, rich experience that my business expects, but do it entirely from models, without custom coding, without custom JavaScript. So there are pre-built controls for things like grids and tree grids and drag and drop and AJAX events popping dynamically and hoverovers and modal dialogues, being able to brand an entire application and change the look and feel, again, through wizards without having to go right into cascading style sheets and some of that nasty code. The end goal is to deliver a user experience that is exactly what you want, no compromise, but do it completely from models, so it's easy to build, easy to change. And then to be able to push that user experience out to different consumers. So have it be browser independent, whether you want to support IE or Safari or Chrome or Firefox. Being able to push it out to mobile devices. So support some of the WebKit capability that's sitting in an Android or an iPhone or an iPad. And being able to push it out as just a small chunk, either via a portlet standard like JSR 168 or 286, or being able to push out a mashup so that you can take a chunk of Pega user experience and build it into an existing web page. And of course, being able to support stuff like internationalization, so having different languages of user experience pushed out to different users, as well as being able to support a user experience for a differently abled user, following something like the guidelines from the American Disabilities Act. Finally, you have your management and reporting capabilities. So Pega has a rich set of business activity monitoring tools to allow me to see where my processes are, how I'm doing against timeframes, what throughput this user or this group is doing. Tools for business people to be able to find their own reports on the fly, slice them, reorganize them, group by this, pivot over by this field, etc. being able to join across multiple tables without having to understand the underlying SQL or write any SQL to make that happen. We also then have the ability, as I said, through BICS, to take that data and push it off to an external data warehouse if you want to combine Pega data with data from other systems, or if you want to do more deep analytics and put the data into dimensional or cube type format to do that. Of course, reporting is great, but real action is even better. So there's a rich set of event management in PRPC that allows me to define things like timed events, what we call service levels, the ability to trigger an action when a particular task or a particular overall process misses a goal or a deadline. External events, the ability to receive events from external systems and correlate those to existing processes or new processes. And perhaps most interesting, declarative events. So because Pega, and uniquely Pega, run a process and rules in the same engine, I can have a declarative event in Pega that I don't need to put specifically anywhere in a business process. Say, for example, if X, Y, and Z about a particular case ever become true, it's potentially fraudulent, stop what you're doing, run a new process. Rather than having to put that check at every step in the business process, I can declare that rule once and have Pega dynamically detect it, trigger the event, suspend the existing process, move it into fraud. So a very powerful model for building event-based, rule-based actions into the overall application without having to build a spaghetti code process to accomplish it. Finally, there's a rich set of automated unit testing at every layer. So I can individually, discretely test these things as I go. I can get very rapid prototyping. I can save the results of my tests and have the system replay them back for me automatically. And there are a series of guardrails that are continually checking what your designers are doing against our best practices. So if we detect that you're building a business process that might be hard to maintain later on, we're going to flag that as a warning, populate it, and escalate it on a report up to a project manager so that kind of stuff can be seen and dealt with later. So none of Pega's applications exist in a vacuum. We always have to communicate with other systems that may be managing part of the process or storing part of the data. So we've built a rich set of what we call connectors and services to go after that. Connectors are outbound calls, so where the Pega engine initiates a call to an external system. Services are the opposite, where an external system comes into Pega to invoke a process or a business rule. At a connector and services level, we've supported what I would call a protocol level. So we have out-of-the-box support for things like SOAP and JMS and MQ and RESTful services over HTTP and SQL and files in and out and email, etc. And whenever possible, we'll consume and publish this dynamically. So if you have an existing WSDL file, we can run a wizard against that WSDL, generate the data access objects, generate the data bindings, and leave you with a shape you can drag right into a business process to call that service. If you have a business process that you want somebody else to be able to call, you can run a wizard that will look through that process, discover the inputs and outputs, and dynamically generate a WSDL or even a Java stub so that somebody else can call into it. And of course, we have all the transformation capability to be able to turn XML into different formats or handle structured or delimited message formats, COBOL copybooks, even some fuzzy logic text parsing to push data both in and out of the system. The key thing to understand is that this technology is not designed to replace or supplant an ESB or an SOA layer that may exist inside your enterprise. Pega is not trying to compete or participate in the ESB space. What we want to be able to do is ensure that we can interoperate very effectively with that layer, both as a consumer and a provider of services. And since most ESB and SOA projects are incremental, and there may be applications that you need for an application that don't have a pretty service for them, we want to be able to do an end run around the ESB if necessary to get the data so that we can pull in and achieve the business objective. All of the assets in Pega are maintained in this enterprise repository. And if you've done some discussion about sort of Pega's strategy and differentiators, you're probably familiar with the concept of the situational layer cake. And that's got a lot of power in terms of being able to deliver both reuse and common assets, common functionality, but still allowing a business to specialize down the axes of product or who the customer is or the region or jurisdiction they're doing business in or even the date and time in which they happen to be operating. But the layer cake also provides some additional technology capabilities that I think are pretty unique to Pega. So as the layer cake builds out these layers, right, and you have enterprise-wide standards and specializations, say for the US or international, and then additional specializations, maybe by retail or corporate, etc. What the user ends up executing at the end of the day is the slice through the layer cake that best represents them, with the more specialized things on top overriding the more general things at the bottom. And inside each of those layers, versioning is also applied. So this means that I can do versioning not at build time, like I do in most traditional coding or BPM environments, but I can push it all the way to runtime. And that allows me to do things like pilot test a new set of processes or new set of rules or new screen. I can roll it out to a set group of users simply by changing their access rights to see that new pilot. Everybody else in the same system still runs the old version. If I don't like the pilot, I can roll it back simply by changing the access groups back, or I can push it out to everybody else by updating access groups across everybody. So in this dynamic versioning, I'm able to test multiple things, do sort of a champion-challenger model. I'm also able to grandfather in-process versions. So in a lot of environments, it becomes really important if I have long-running processes and I release a new version of the business process, I only want that to impact new processes. I want my existing processes to keep following the old path, or else they're going to fall off the rails. So in Pega, with the layer cake, I'm actually able to support that. And over time, I'm building an archaeology of how my process and rules have evolved, so that I can always go back and document or even execute my processes and rules exactly how they would have run 6 months, 2 years, 5 years ago, which can be very powerful from an auditing and compliance perspective. So let's talk about how the engine works. At design time, as I'm authoring my rules and my process in my browser-based environment using my browser-based tools, what I'm really generating are XML documents that represent those models and persisting those documents down into the repository. So that's pretty straightforward. At runtime, the system is designed so that any request, whether it's a user coming in through a screen or a web service or an API call or a batch file, looks like a sort of lowercase s service generically to the system. And we do that by taking the data from all those requests and populating them into a working memory structure that we call the clipboard. It's an XML Java sort of working memory area, and it works to normalize and isolate the processes and rules from the way they are being called. The result of this is any process I build in Pega can be called via a Pega UI, via a web service, via an API, via batch file, etc. So once I've invoked that, in most running systems, I've already generated Java classes that represent this process, this rule, this screen, etc. So I just execute them right out of the class loader and I'm done. If, however, the engine detects from the repository that something has changed, or if it has never run this particular version of a process and rule before, it will go out to the repository, dynamically assemble and compile the Java classes for that rule, and cache them and execute them, so that anybody else who then comes in to do that same process and rule is just firing Java from memory. And of course, Pega has tools that allow you to pre-do this, so that all of those Java classes are preloaded, and we actually store the Java classes back down into the enterprise repository, so that if I'm running in a multi-node system, one node can assemble a process, and everybody else can take advantage of it. The result of this late binding to Java is that I get all the execution speed and tunability I get from a Java application, but I can do things like run multiple versions at the same time, manage and have the specialization that the layer cake provides, do real-time change without deploying a whole new system or bringing the system up and down. So I get a lot of power while keeping all of the speed that I had in a Java application. If you drill down into the engine itself, you can break it up into 4 big areas. So there's the session services, which are responsible for things like managing a user session, managing authentication, authorization, managing some intrusion detection checks that we do. The data services, which handle access to the database, do the object relational mapping, support things like encryption at either a field or an object level, both in the database and up into memory. I've got the execution services, which are responsible for actually executing my business processes and business rules. And that generally takes advantage of the generation services, which know how to take a model of a business process or the model of a business rule and turn it into executable code. So the big remaining part of the Pega engine is the actual generated code itself that represents the processes and rules and screens and integrations that I actually want to generate and run. When I think about how I authenticate users into this system, Pega comes out of the box with a security model that consists of operators, which are then mapped to access groups. So, that's what kind of rights they have, what kind of roles they have, and what applications. And an application in Pega terms represents a particular horizontal slice through that layer, vertical slice through that layer cake, as well as organizational information about the user. And we come out of the box with our own authentication that uses passwords, and the passwords are stored down in the enterprise repository. For most customers in production, they aren't using our authentication. So we provide a layer of what we call authentication and authorization services that basically allow us to plug a user into our authentication structure via a model operator concept. Even though the actual information about that user, including a high degree of their authorization, may be coming from an external system. And we support plugging into single sign-on infrastructures like Integrity SiteMinder or Tivoli Access Manager. We can plug into LDAP directories or use any of our connectors to go out to some custom authentication service or authorization service. And we can talk to the container through Jazz to get authentication and authorization information from it. And we do make some design time decisions about how much authorization lives outside of Pega. Generally, it tends to be coarse-grained stuff like user-to-role mapping, and how much lives inside Pega, which generally tends to be things like the actual definition of what a role can do for a particular process. But again, that's a fuzzy line that's often driven by what the infrastructure of the customer looks like. When you think about the physical architecture of how this deploys, as we've said, we've got the enterprise repository, the work database. Pega is designed to support vertical and horizontal scaling, so I can run multiple PRPC engines, and in this case an engine is really just a JVM running Pega. I can scale those vertically by bringing up more JVMs on the same piece of hardware, or horizontally by bringing up new pieces of hardware running Pega JVMs. And then I can connect my users, my services to that, and stick a load balancer in front of it all. For users that are stateful, so people who are coming in through the Pega UI, we recommend using a sticky load balancer so that users get redirected to the same session. Although we can reload the session from disk, it doesn't make sense to do that at every request, so we'd rather be sticky if we can. The services are generally stateless, so the load balancer can stick them wherever they want. One of the interesting things that Pega allows you to do, in addition to this sort of traditional JEE style deployment, is you can also take the entire Pega engine, embed it inside of another application simply by putting the jars inside the class path of the other application, and run it entirely inside the other app. So some of our customers that do a lot of business rules-based things, where they want to call Pega very rapidly without incurring the overhead of parsing XML and serializing data and going across the network and unparsing and remarshaling the XML, they call us directly via the JSR94 API, which allows our application to actually run embedded inside the same Java space. And we also support batch. So taking in batch file feeds, whether we're doing that at a Unix level, sort of via a cron job, or whether we're actually running inside a COBOL or JCL batch job up on a mainframe running ZOS. From a migration and deployment perspective, one of the things to keep in mind is that we don't deploy code. The EAR file, as I said before in Pega, doesn't change. Rather, what we're going to move is the definitions of the models themselves from the development repository to QA to production. So if you have your development environment and its repository, QA and its repository, production and its repository, Pega provides both online tools as well as batch tools, Ant scripts, to extract your rules and processes and screens, etc. out of development, put them into a platform-independent format, usually a zip or .jar file, and then push them out to your QA environment, production environment, and load them into the repositories there. For a lot of our customers that use some sort of centralized source control like Subversion or ClearCase, They often take that zip or jar file, push it into that versioning repository, and then use our Ant scripts to automate pushing it to development, production, etc. When you're thinking about how you monitor your Pega environment, we provide a lot of tools to help you do that both at design time and at runtime. So there's a tool called Tracer, which is effectively a debugging tool. It allows you to do things like set watch variables and breakpoints and debug a Pega environment, not at the code level, but up at the rule level. So what the processes are doing, what rules are being fired, etc. There's also a series of performance alerts built into the technology. So Pega allows you to see the performance of what it's doing. We instrument it all for you automatically. And you can do that either on demand, ask Pega to tell me how much CPU did the process I just ran take. But we also have alerts built into the system. So there are about 35 configurable thresholds, and if we ever cross a particular threshold, so a database request that takes longer than 500 milliseconds or returns more than a certain amount of data, or a user HTTP request that takes more than a second to complete, we actually write an alert out, generally to a log file or to a log4j appender, that has the details of what was run, who the user was, what process they were running, what they were doing, what the session looked like at that time, other alerts that may be related, etc. So that you're always getting real-time information about what's going on inside your system. We provide a series of JMX mbeans that allow you to manage and see the user sessions, background processes, memory utilization of Pega caches, etc. And we even have a database tracing tool that lets you see the low-level database operations that the system is doing. We have a framework, as I said earlier, called AES, or Autonomic Event Services. And what it knows how to do is take all those alerts that Pega may be generating and basically apply case management and rules to them. Aggregate them, correlate them, prioritize them, so some alerts are more important than others, especially if I'm having 100 per hour rather than others as opposed to like 10 every day. Push them out to work queues for people to actually work, and in some cases go out and get more information about them. So AES may detect a database query that's running slow, go back to Pega, get some information about the database table, figure out that an index is missing, and actually suggest to a database administrator that they add an index to the table to fix this query. And we've designed this system to get big. So we have done performance testing with IBM both on distributed platforms, P-Series and Linux, as well as on the mainframe, ZOS and ZLinux, that prove we can get into the tens of thousands of concurrent users, maintain a near linear or linear scale curve up into that 30,000 user plus range, and deliver a response time of, in some cases, less than 50 milliseconds. So the technology is proven to grow very large, and we have customer deployments that are getting into the 10,000, 15,000 concurrent user range in terms of what they're doing on Pega technology. So that's a quick summary of the architecture of Pega and PRPC and our BPM product. My name is Don Sherman, and thanks for your attention today.